So today we are going to be starting a real-world application of systems of equations. And yesterday, I believe I went over just the idea of this, but I'll go over it again. And this is very similar to the linear fitness activity that we did when we were just working with one equation. But now we have a different situation. Your family opens a bed and breakfast. They spend $600 preparing a bedroom to rent. The cost to your family for food and utilities is $15 per night. Therefore, the cost in dollars that your family must spend is represented by the equation C equals 15x plus 600, where x is the number of nights. So this is one of the equations we're going to be using for this problem. C equals 15x plus 600. They tell us x is the number of nights, and then C stands for the cost. Your family then charges $75 per night to rent the bedroom. Therefore, the revenue, the money that they earn in dollars, is represented by the equation R equals 75x, where x is again the number of nights. Completing the table below to determine how many nights your family must rent the bedroom to break even. So the break-even point for a situation like this, if you have a company, or if in this case a bed and breakfast, you spend money to clean it, to provide whatever food, and that's your cost. That's this first equation here. This is how much it costs to actually have the bed and breakfast open, because it's $600 to prepare the bedroom and then $15 per night to probably clean it and provide all of the drinks and food and whatever you would need there. And then they charge $75 a night. So the break-even point is when your cost equals the amount of money that's coming in. So if you ever have your own company, when you graduate high school, or maybe some people might be entrepreneurs now, whatever you're doing to make money, the money that comes in has to be more than the money that you spend. For example, I have one of those Cricut machines that takes like vinyl stickers, and I can take any cup and I can put the vinyl on it. And if you go on Etsy or whatever, and if you're looking for something that just says your name, they might charge you like $30 and then plus shipping and all this nonsense for like any type of cup. Let's say it's not even a Yeti. Let's just say it's like a cheaper plastic cup with your name on it, and they might charge you like $25. Well, you can get the plastic cup at the dollar store, and then the vinyl actual stickers cost, I don't know, maybe another dollar, let's say. So it costs $2, and then plus your time, and I guess that has some sort of value to it as well. But if it costs $2 for me to make that cup, and then I go on Etsy and I sell it for $20, then I'm making how much money? 18 bucks. So the break-even point would be when your cost exactly equals your revenue, but anything more than that, you're actually making money. In this problem, we want to see when they break even, when the cost for them to have the bed and breakfast is equal to the amount of money that they are spending. In that example I just went over, let's change it. Let's say I don't use the dollar store plastic cup. Say I actually do get a Yeti, but it was on sale. And say it was like $15. The Yeti was $15, and then I use a glitter sticker, and it ended up being $5. So altogether, the $15 cup plus the $5 sticker, that equals $20, and then I sell it for $20. I didn't make any money because the cost for me to actually physically make that cup with the name on it equaled the amount of money that I was selling it for. It's called the break-even point. What we're doing in this example is figuring out the break-even point when the cost for the bed and breakfast is equal to the revenue, the amount of money that's coming in. There's a really easy way to get these answers for the table, and it's using a graphing calculator. If you have a graphing calculator, I would open it up. If you downloaded the Calculate 84 app on your phone, I would get that out and open that up because it's really easy. If not, you have to do a ton of math. So I'm going to show you what steps to take in the graphing calculator to fill out this table. And then after you fill in the table, then you're going to use the table of values to graph. So this takes forever to load, but the first thing you're going to do if you want to create a table is you have to put the table of values into the y equals screen. So you'll hit the top left-hand corner of the y equals button. And right now I have two equations in there. They're actually the equations from the linear fitness activity, so I'm going to erase those. And the equations I'm going to put in are the two equations that they give us in the problem. So they don't use x and y, they use c and x and r and x. But the c and the r represent y, so it's really like y equals 15x plus 600. And if you have a graphing calculator either on your phone or if you actually physically have one, please follow these steps with me. And then if you push the arrow down, you can go to the next equation. And the next equation that we have is r equals 75x. So this will just be y equals 75. And then the x button is the button right next to the alpha button to the right. It has like xt. It has like a circle with a line through it. It's called theta. And then an n, that's the x that you need. Once you have these two equations in the y equals screen, what we will need is a table because we want to fill out this table below for both of the values for the cost for 0 nights, 1 night, 2 nights, 3 nights, and so on, all the way up to 11 nights, and then same thing for revenue. So what I'll do to get there is hit the second button and then the graph button, and then it should open up a table. Mine started right at 0, which is exactly what I need. So the first one that I have here, let me try and fit both of these on the same page. The first thing that I have here in my table is the first equation, which is the cost equation. So what you can do is you can just start writing in these numbers. So for 0 nights, it costs $600. So I know that I can just fill this in from the table here. 0 is $600. And I'm looking at the blue here. For 1 night, it's $615. For 2 nights, it's $630. And I could just keep filling these out. If you're looking, though, at the pattern of these numbers, what's happening each time for each number of night? What's the total cost increasing by?
$15.
Yeah, $15. And where can we see that in the equation? What's the slope of this equation? 15. So it's going to increase each time by $15 because that's the slope. So I'm just basically either copying these numbers down or just adding 15 to the previous one. All I can reach on my screen right now is up to 7, but you guys should go up to 11. Okay, and then once you get all of those numbers in, then you can look at the other equation. The other equation is the revenue equation. So in this case, it's red, so I'm going to change mine. For 0 nights, it's $0, which makes sense because if you don't have anybody coming in, you obviously make no money. And then for 1 night, it's $75. And then after 2 nights, $150, $225, $300. What's happening each time? For each night, it's increasing by what? 75. And we can see that as well with the equation slope, it's increasing by 75. Okay, and I can only go up to 7, but you should go up to 11. Okay, there we go. All right, once you have all of these numbers in for the table, these table values represent ordered pairs. For example, for 0 nights, it costs $600 just to get the bed and breakfast room ready. So this is the initial amount. For 1 night, it would cost in total $615 because it must cost $15 per night to provide the food and drinks. For 2 nights, it would cost in total $630. So this is the total cost that the family would have to pay to actually host people in the bed and breakfast. This equation represents for 0 nights, the money that you make is $0 because nobody's staying. After 1 night of staying, they would make $75 because after 1 night, it's $75 a night. 2 nights, it's a total of $150. 3 nights, it's a total of $225. What we're going to do now, I know my numbers are going to be all a little off, is take these values and we're going to create a graph from them. So now my values are all messed up, but remember this was 0, 1, this is X, this is C, and this is R. But this was 1 all the way up until 11. Now what you're going to do is take these values and graph them above on the actual graph here. So you're going to have 2 separate lines. So because I can color coordinate, I'm going to do the cost line in blue. The first ordered pair I'm going to graph is 0, 600. So that means on the x-axis, which we can see is this line here, I'm going to go to 0, which is right here at the start, and I'm going to go up to 600, and I'm going to make a point. And then 1, 615. So when I go to do this one, it's not going to be perfect. So if you don't want to do things that aren't perfect, you can kind of skip until you see another one that's perfect. Like 5, 625, or sorry, 5, 675 is a perfect point because 675 is on the graph, and so is 5. So I might just skip all the other points in between and just plot those. You can estimate though. And you could just say, okay, 1, 615 looks like it could be about here, and this could be about here. Like, you could estimate it, but it will be a straight line. So if you don't want to have to do that, you don't have to. And then it looks like 10, 750. Oh my gosh, I'm too short for this one. 10, 750 is a perfect point, so we can put that there. And then we can draw our line to the best of our ability. That line represents the amount of total cost it would be for the family to create the bed and breakfast and host it. Then in red, it's going to be the amount of money that the family would make when people stay in there. So the first point would be 0, 0. So I'd make a point here. The next one is 175, 2, 150. Actually, all of these points are right here on the line, it looks like. So then I can just connect my line. And then I have both lines on the graph there. The red is representing the revenue. The blue is representing the cost. I did forget to label what X represents, X and Y. It's important to write on your graph. X is going to be the number of nights. And Y just represents cost. So it's important to just write that. And then with systems of equations, what we're trying to do is find when the 2 equations cross. In this case, that would be the break-even point. Where do these 2 lines cross? Where does the blue line cross with the red line? And I know my lines aren't perfect. Hopefully yours are a little bit better. Where do these 2 lines cross?
10 and 750.
Yes, I can see it on the graph right here that the 2 lines cross at the point 10. 750, and I can also see it out on the table. You can see here when X is equal to 10, both the cost and the revenue is equal to the same number. They're both equal to 750. That means the break-even point is 10, 750, which also means at 10 nights, the cost and revenue are equal. If the red line represents how much money you actually are making, you don't want to have anything less than 10 nights. Because if you look at all of these numbers, you are losing money for anything here. So whenever you have a business, you're going to lose money for a certain point until you hit that break-even point. But anything after 10 nights, so as soon as they rent out the bed and breakfast for the 11th night, you can see at the 11th night, the revenue that they make, the $825, is more than the $765. So they will start to make money overall after they have 11 stays. Okay, so that's how linear equations work. When you have systems, which means two or more, you're looking for when the two lines cross. In this case, we're talking about like a break-even point for a company. If we flip this over to the next page, we are now going to just practice graphing systems of equations. And one way you can solve is by graphing. There are three ways actually, but we're going to start with graphing. We already know how to graph from the last chapter, so this shouldn't necessarily be new information, but now we're going to graph two lines on the same exact graph. So, in example 1, it says use the graph to solve the system of linear equations and write your answer as an ordered pair. Number 1 has both of these lines graphed for you. X minus y equals 4 and 4x plus y equals 1 are graphed. Now, these ones are a little bit, if I said graph this, you would have to do some things because we know only how to graph in slope-intercept form and point-slope form, and neither one of these equations are currently in one of those forms. But in example 1, they only want us to just solve the system. Solving the system means find the point of intersection. Okay, so we're only looking to solve the system and finding the point of intersection. That's all we mean. So if I'm looking at this number 1 here and I want to solve the system, that means what ordered pair represents the intersection point. So you just would look at the point here. I can see these lines clearly cross right here. This ordered pair is at 1, -3. So the solution would be 1, -3. It's as easy as that. Now, it is also helpful to see what the solution means. The solution means that when the point 1, -3 is here, it works for both equations. So if I replace in a 1 for x and a -3 for y, this would say 1 minus -3, and that does equal 4, since 1 minus -3 is really 1 plus 3, and it equals 4. If I replace in 1 for x and a -3 for y, 4 times 1 is 4. 4 plus -3 equals 1. So you can see that the solution will always work for both equations. For number 2, these equations are already graphed for us. I can see that the two lines are here. To solve the system of equations, we're just finding the solution. You just look where the lines cross, and that is it. So it's very easy to do this. You then would just say, okay, well, this point is at -4, 5, that's the solution. That's how we would solve it if it was already graphed for us. But that's not how they're always going to be. That's pretty simple. In the next example, we're actually solving by graphing ourselves. So this is how the questions are going to look normally. So in letter A, we have two equations to graph, and this is going to be a refresher from what you did in the last chapter. So we're going to graph both equations on the same exact graph. Let's graph y equals -2x plus 5 first. So if I'll do this one in blue, y equals -2x plus 5. Remember, this is in slope-intercept form. This is considered the y-intercept. So that means on the y-axis, I would plot a point at 5. This number here is the slope. The slope tells you what to do. Since the slope is -2 and slope is a 2-step process, we would make it -2 over 1, and that means from your starting point, go down 2 and to the right 1. So I will go down 2, 1, 2, to the right 1, and make a point. All you need is 2 points to make a line. You can be done at this point, or you can just keep going if you prefer. I'm just going to keep going because I want my line to be perfect, as perfect as it can be. And then, to the best of your ability, connect those points by a line. And that line would represent y equals negative 2x plus 5. Okay, in the next one, I'll just change my color so it's better for you to see. I'll use green for y equals 4x minus 1. Remember, this is your starting point. This is the y-intercept. So on the y-axis, I'll plot a point at negative 1 because the minus 1 means it's a negative 1. This is my slope here. It's another whole number, so I'm going to put a 1 underneath of it, 4 over 1. And because it's a positive, that means I should go up and over, not down and over. So from my starting point, I'll go up 4, 1, 2, 3, 4, and over 1. And I can already see where these 2 points are going to intersect because I made a point directly on one of the other points. So I'll connect those 2 points because I can only fit those 2 on there. And then after you graph both of the lines on the same exact graph, then the last thing that you do is identify the solution. And I'm only writing solution because this is just like notes. The solution would then be what point? What's the solution of this system?
1, 3.
Yep, 1, 3. Now, it is always helpful to make sure that you didn't make a mistake. You can make sure you didn't make a mistake by replacing in 1 for x and 3 for y and making sure it works for both. 3 equals negative 2 times 1 plus 5. That's true. Because negative 2 times 1 is negative 2, and negative 2 plus 5 is 3. And then 3 equals 4 times 1 minus 1, which is also true. 4 times 1 is 4 minus 1 is 3. It will always work for both when you solve by graphing. Okay, so that's how you do it. It's pretty simple. The only thing is that both equations have to be in a certain form in order to graph, and sometimes the equations are not already in that form for you. We're going to do one more together, and then you guys are going to do the 4 on the back. So for letter B, I'll do y equals x plus 4 in green. This one is going to also start at 4 because the y-intercept is 4. And since this just says y equals x, that means the slope is just 1, since there's an invisible 1 here. A slope of 1 means from your starting point, go up 1 over 1, up 1 over 1. So there's 3 points on the line. You can also go down 1 to the left 1. To get even more points. So here's my line for y equals 1x minus 4. In blue, I'll graph y equals negative 1x minus 2. For this example, this equation is going to start at negative 2. And this one has a negative slope, a negative 1 slope. That means to get to the next point, I go down 1 to the right 1, down 1 to the right 1. To get more points on this side, I can also go up 1 to the left 1. And when I do that, I can see the points they will intersect. The solution of the system is where they intersect. And in this case, the solution I can see is right here. The solution to the system would be negative 3, 1. So once you have that written down, I want you to please flip over to page 8. There are 4 practice problems. I don't think that we'll be able to do all 4 and go over them in the next 10 minutes, but let's see how fast you can graph. Maybe we can. So go ahead, complete numbers 1, 2, 3, 4 on the next page, on page 8.